Hi, welcome to another video on the chain rule. In this video I'm going to show you guys another example. Alright, so here I have f of x is equal to 4 multiplied in parentheses 5x cubed plus 2 and the whole thing to the power of 6. Alright, so as I mentioned just now, what we could do is to apply binomial expansion, but that's going to take us a very long time, and we will have a lot of stuff after the expansion. So what we're going to do right here is we're just simply going to apply the chain rule. Okay, but in order for us to apply the chain rule, we need to kind of observe the equation first, right? Observe our function here and see what we have, right? So right now what I have here is just a number, right? And then I sort of have this cubic function to the power of 6, right? This is kind of what I have right now, right? So I have a cubic function, and the cubic function is gonna the cubic function has exponent of 6. So in the previous video I also kind of used a red box to represent the function that's inside, and so let's continue using that. Okay, so the chain rule, let's apply the chain rule. So now my f prime, like I said, we need to be very careful with the notation in this chapter, right? So my f prime, which is the derivative, is simply the 4 is just going to stay there, and what we're going to do is to apply simple power rule to the box. Right, the 4 stays there, so if I apply power rule, the 6 will come down, right? The 6 comes down. So 4 multiply the 6, and we will have the box itself. So I'm just going to copy the box, which is 5x cubed plus 2, right? And then I'm going to drop this 6 minus 1, so I will have 5. So I'm just applying simple power rule to the box. But I'm not done yet. This is chain rule, so there is going to be a chain reaction. So after applying the power rule to the box, I need to find the derivative of the box, right? I need to find the derivative of the box. So if I differentiate this 5x cubed plus 2, I will get 3 comes down, multiply the 5, I'll get 15x squared, right? 15x squared. The plus 2 just goes away, and I would recommend you guys to use the parentheses to help you out, just to avoid any possible mistake. So finally 4 times 6 gives us 24, and here I will have 5x cubed plus 2, the whole thing to the power of 5, and multiplied by 15x squared. 15x squared. So right now this is already good, but to make it even better, I will multiply the 15 to the 24 and move the x squared to the front, and that gives me 360. 24 multiplied 15 gives me 360 x squared, and then this 5x, sorry about the bad handwriting, 5x cubed plus 2, the whole thing to the power of 5. Alright, so this is it. This is my derivative of my f of x using the chain rule. Alright, let me show you guys another example. Okay. Alright, so here is another example. So my equation y is equal to square root of 4x squared plus 1. Okay. Now it's always easier for us to write the radical signs using exponents, right? So I can change this, and that will become 4x squared plus 1, and the whole thing to the power of half. Okay, and I can see that what I have here is a quadratic, right? A quadratic function, a quadratic equation. This 4x squared plus 1. This is quadratic inside a square root, right? A quadratic. This is my quadratic inside the square root function, right? So we kind of have a function in the function. Okay. So I'm going to say this, whatever is inside, that's my box. So that's my box, right? And I'm going to apply chain rule to that. So dy dx is equal to, so to apply chain rule, we're always applying, we're always differentiating the outside function first. So here I'm just going to pull this half to the front, right? Pull the half to the front. So I will have half, apply simple power rule to the box. So now the box is equal to 4x squared plus 1. And now the power drops by 1, so half minus 1 will give me negative half, right? Negative half. Okay, but I'm not done yet because it's chain rule, so there's a chain reaction. Okay, so I need to differentiate the box. Inside the box, if I define the derivative of this quadratic function in the box, I will get, so 2 goes to the front, multiplied by 4, that gives me 8. And x, the power of 2 drops by 1, then I have 8x. The 1 goes away. So I'm almost done. Now, half multiply 8x, that gives me 4x. And the rest, I cannot simplify them, so I'm just going to copy them. Plus 1 to the power of negative half. Alright, I think I still have a few minutes for another example. So let me show you another one. Okay, so now this is the last example in this video. Okay, so here I have f of x is equal to e to the power of x squared. So I need to ask myself, right, where do I put the box? Because all these examples that we have done, we have always used the red box to kind of identify the inner function, right? So I need to figure out which one is inside, which function is inside which function, right? So here e to the power of x squared, which means I can say this is, I'm going to put the box here, right? So this function right here, this is simply e to the power of something, and that something right now is my x squared. So what we have here is we have a quadratic function inside the exponential function. Alright, quadratic function inside the exponential function. Okay? This question is a bit harder to see. Right, so previously, what we have here is we have a quadratic, this is very obvious, we have a quadratic inside the square root function. Right? And then we just apply the power rule to the square root function first, and then the second step is to find the the derivative of the quadratic, right? So here, for this f of x is equal to ex squared. This is a quadratic function inside an exponential. So that's why I put a red box on the quadratic. Okay, so now my f prime, the derivative. Right? So what I'm going to do is I'm going to differentiate this e to the power of box. Right? Whatever it is, when I differentiate exponential functions, I'll get itself. So I will have ex squared. Okay, so I'm just differentiating the e to the power of box. So I will get e to the power of box, and right now my box stays the same, right? And then not done yet. Chain rule, this chain reaction. So now I need to differentiate the box. What's inside the box? I will get 2x. And I simplify this a little bit. I'll get 2x e to the power of x squared. Okay. Alright, the last example is a bit harder to see, but ultimately when we are trying to apply chain rule, we first need to figure out what type of a function is inside another type, right? And in this example, we have a quadratic inside an exponential. Okay, so good luck in the exercises. Help each other out. The chain rule, like I said, it's very important. It's a very important skill. All right, and I'll see you guys in the next video. Bye.